All right, so now we're ready to look at some of the other trig graphs. And you'll hear me say this a lot, but if you know sines and cosines, you know pretty much everything. One of the identities we've briefly mentioned in the course is the fact that cosecant is the same thing as 1 over sine of x. And when we look at that, what we do is we make two basic observations. The first one, which we'll get to here in a little bit, is the fact that sine is the reciprocal of cosecant and vice versa. So the graphs essentially are going to look like they're reciprocals of one another. The other thing, and probably the most important thing to take away from this, is by looking at the cosecant as 1 over sine, we can see that sine of x cannot be 0. And so we have to make sure that we don't include the values that would make sine of x 0. So just as kind of a review more than anything, I'll go ahead and I'll quickly put up the graph of sine of x from negative 2 pi to 2 pi. And hopefully you're able to put these together pretty quickly at this point. Again, sine's bounded between 1 and negative 1. Sine starts at 0 and goes up. And again, I'm just doing this pretty quickly. This isn't actually going to be part of the graph, but it'll certainly help us get there. And then if I connect the dots, and there's our graph of sine. Now, the reason I did this is because we're not to the point of solving trigonometric equations yet, so we can't figure out these x values without looking at a graph. But the graph will tell us everything we need to know. The values for which sine of x are equal to 0 would be wherever the graph crosses the x-axis. So in all of these spots, this is where the x values are that would create a 0 in our denominator. So just like from algebra, if you've got a 0 in your denominator, you're not allowed to have it in the domain. You're going to have these placeholders in here that don't allow there to be graph. And so these are going to be our vertical asymptotes. So vertical asymptotes for the graph of cosecant at any place sine of x would equal 0. Okay? And then as far as the reciprocal part goes, we're just going to take each individual piece and almost flip it around. It's what it's going to look like. So instead of having it look like that, I'm going to take it, I'm going to flip it, and it's going to look more like this. And similar down here, and right here, and finally in the last region. So the red and the green there, that's the graph of cosecant. The sine's not really part of the graph. It can be helpful in putting it together, but the red and the green that I have on the screen, that's the graph of cosecant. Now, because of how it's divided, it doesn't really make a whole lot of sense to talk about domain, so instead we talk about the asymptotes. And they're vertical, so they would need to be written as x equals. And as you can see, they're at negative 2 pi, negative pi, 0, 1 pi, 2 pi, 3 pi, and so on. So they're going to occur at k pi. And that k, if you remember, that's an integer. So the asymptotes are going to be at integer multiples of pi. The range, and this is where you'll want to be real careful to understand the blue that I have drawn in there is not actually part of the graph. The range would be a negative infinity to a negative 1 inclusive, union 1 to positive infinity. We would have a period to discuss, the distance required to complete one cycle, and because cosecant comes from sine, they'll have the same period as well. And then finally, the fundamental cycle, the part that we're going to graph, FC, fundamental cycle, will be the 0 to 2 pi again. All right, so hopefully you were able to put together a graph of secant in a similar way. So we'll now take a look at the graph of tangent. So tangent, remember, in terms of sines and cosines, would be sine of x over cosine of x. Now, to put this together, we're going to actually look at three really important observations. The first observation is, as you can probably suspect, cosine can't be 0. So, as you saw from the graph of secant, this is going to imply we have vertical asymptotes at x equals pi over 2 plus k pi. So the same asymptotes you just found for secant a moment ago. The next observation to make is that tangent of x equals 0 when sine of x equals 0. In other words, tangent of x equals 0 when x equals k pi. So that's where on the graph our tangent will be equal to 0 or be touching the x-axis. The third bullet point is that tangent of x equals 1 when sine of x equals cosine of x. Now, again, we haven't solved trig equations yet, so I'm actually going to come down and I'm going to call this just an example for a moment. We'll have to come back and look at another example shortly, but for now, just as an example, if we wanted to know tangent of pi over 4, well, I would draw that up there in the first quadrant. I'd have a reference triangle of 1, 1, square root of 2, and you can see that tangent of pi over 4 is equal to 1. So when this x happens to be pi over 4, we know that tangent of pi over 4 is going to be 1. So that, again, that's just an example, and that's not the whole picture, but that's enough, I believe, to get us through where we're going. All right, now, a couple things as well before I put this graph together entirely. First thing worth noting is that this pi over 4 is an important number. So our tick marks now aren't going to be every pi over 2 units, they're going to be every pi over 4 units. So I'll have a pi over 4, a pi over 2, a 3 pi over 4, and a pi. And in the other direction, we'll have a negative pi over 4, negative pi over 2, negative 3 pi over 4, and a negative pi. I know that from the first bullet point here that the vertical asymptotes are every pi over 2 plus k pi units away. So in the picture that I have drawn, negative pi over 2 and pi over 2 are where they'd be. I also know that from this guy that every place that sine is 0, tangent is 0. So my tangent curve is going to be 0 there, there, and there. And then the other point that I just put together in this example is if tangent at pi over 4 is equal to 1, then at pi over 4, I'm going to have a point up here at 1. So let me go ahead and put that in. Pi over 4 would be a 1 right there. And then just as kind of a second example to look at to build this picture, I'm going to take a closer look at negative pi over 4 as well. So tangent of negative pi over 4. Well, if we draw our triangle, we have a pi over 4. That'd be a negative 1, a 1, and a square root of 2. Tangent of negative pi over 4 is equal to negative 1. So that puts our other point down here at negative 1. Now we're ready to connect the dots. If I connect the dots understanding how the graphs work around asymptotes, you can see that in the middle portion I start low and I kind of sweep through those 3 points and I go back up high. And with these two examples, I wanted to make sure to be clear, those are examples. When we construct these triangles, it was all about the unit circle, and with the unit circle, we can keep going over and over again, and you see the same pattern. And so that's the same way with these graphs. These graphs are going to just be the same pattern over and over again. So even though I don't have a whole lot of things marked beyond this middle region, it's just going to keep repeating itself over and over again. So I'm able to see the pattern and sketch in the remaining portions. Now, That's the graph of tangent. Because of the asymptotes, again, it doesn't make much sense to talk domain, but for the asymptotes, we've already discussed that they're going to be at pi over 2 plus k pi. The range would be negative infinity to positive infinity. The period, now this one again, you be a little careful, okay? Distance required to complete one cycle. So from here to here would be one cycle. And because of our tick marks being a little different, our period is going to be a little different. The period is actually just going to be pi for tangent. And then finally, the fundamental cycle, the part that we're going to graph over and over again, even though we know it goes on forever in both directions, the fundamental cycle for tangent would be a negative, oops, in the wrong bracket there, negative pi over 2 to pi over 2.